After 160 days in transit, a localized dust storm strikes with the force of an explosion. Astronaut William is thrown into the red haze, separated from his crew as they scramble for the ascent vehicle. When the winds finally settle, he is alone on the surface of a dead planet. Survival is now a matter of inventory. His habitat holds exactly 230 days of breathable oxygen. His food supply is even leaner: 3 standard ration boxes meant for a mission that has already left him behind. The Martian environment offers no margin for error. While days hover near -15 degrees Celsius, the nights see temperatures plummet to -125. At this extreme, the habitat's thermal systems must work perfectly. If the internal heaters fail for even an hour, the air inside will freeze solid. Science has taken a back seat to the raw demands of thermodynamics. Counting every breath, every single calorie, and every kilowatt of heat must be perfectly calculated to maintain the status quo of a living pulse against the hostile physics of the void. Staying alive requires a punishing, repetitive routine. Every morning, William clears the fine red dust from the solar panels to keep the batteries charging. Inside, the only constant companion is the rhythmic, mechanical hum of the oxygen generator. From the surface of the red dunes, home is nothing more than a tiny pale blue dot suspended in a dark sky. It is 140 million miles away, a distance so vast it renders the idea of rescue almost impossible to process. The mechanical struggle is constant, but the psychological toll is heavier. In total silence, the mind begins to look for reasons to stop fighting. The greatest threat isn't the cold or the empty rations. It is the weight of absolute solitude and the urge to simply surrender. As the ration box is empty, William faces starvation. He cannot simply plant seeds in the ground. Martian soil is saturated with perchlorates, toxic chemicals acting as a systemic poison to Earth-based organic life. To bypass the chemical barrier to life, William mixes a sample of Earth soil into the Martian dirt, introducing vital bacteria. These bacteria colonize the mixture, neutralizing perchlorates and breaking down minerals into bioavailable nutrients. Slowly, this biological engineering turns toxic dust into fertile soil. He plants potato seeds, regulates moisture, and waits. After days of uncertainty, a single tiny green sprout breaks through the red surface. Mastering this biological cycle provides proof of control. This small crop anchors William's sanity, demonstrating that human ingenuity can sustain life within a void. To sustain the plants, William has to harvest water from the air. Every evening, he places steel plates outside. As the temperature crashes, the thin Martian atmosphere reaches its dew point, depositing a microscopic layer of frost across the metal. He retrieves the plates before the morning sun can sublimate the ice. Inside the habitat's heat, the frost melts, providing the liquid necessary to keep his crops alive. Even as his biological systems thrive, his technology fails. He manages to power up an old communication relay, hoping to bridge the gap to Earth. The screen flickers, runs a diagnostic, and settles on a cold, unblinking offline status. Success in agriculture cannot fill the silence. Without human connection, survival becomes an agonizing waiting game, proving the vacuum of space is as much a psychological state as a physical reality. Disaster strikes in the form of a localized meteor shower. A series of high-velocity impacts destroys William's external sensors and erases the automated location beacon that would allow Earth to find him. He is now invisible to the rest of the solar system. This trajectory map shows the scale of the rescue attempt. Mission Control launches an experimental nuclear thermal propulsion module. It will reach Mars in record time, but without his coordinates, the lander is aiming for a search zone spanning thousands of square miles. By day 222, William's physical systems begin to fail. Starvation has hollowed him out. He can no longer process the raw, meager potatoes he managed to grow. Exhausted and freezing, he reaches the decision to finally let go. Even the most resilient mind faces a rigid biological limit. When the body can no longer generate heat or process fuel, the will to survive finally breaks under the weight of cosmic indifference. In a final act of closure, William steps outside to release a signed crew balloon into the thin atmosphere. It is a silent, emotional goodbye, a tiny piece of color, drifting into the dark. The NTP module's sensors are programmed to flag any object that violates the uniform visual and thermal profile of the Martian surface. As the balloon reaches the upper atmosphere, its distinct movement and color provide a target for the module's scanners to lock onto its precise coordinates. The lander touches down within an hour. It brings oxygen, high-density rations, and the one thing William needed most: the sound of human voices. His isolation is over. Surviving the universe requires mastering the mechanics of soil, water, and heat. But the most difficult engineering project on Mars isn't the habitat or the crops. It is the human mind's refusal to be extinguished by the void.